For centuries, the universe seemed to run like a well-oiled machine. Isaac Newton's laws of motion elegantly described the movement of planets and apples falling from trees. This framework, known as classical mechanics, gave us a deterministic view of the universe. We could predict the future position and momentum of an object with perfect certainty if we knew its initial conditions. The universe was like a giant clock, ticking away with predictable precision. Physicists felt confident in their understanding of the cosmos. Classical mechanics explained everyday phenomena with remarkable accuracy. From the trajectory of cannonballs to the flow of water, it provided a solid foundation for our understanding of the physical world. It was a time of great intellectual confidence. However, as scientists delved deeper into the microscopic world, they began to encounter phenomena that defied classical explanations. The universe was about to reveal a whole new level of strangeness. As scientists explored the world of atoms and light, they stumbled upon perplexing observations. One such mystery was blackbody radiation, the light emitted by heated objects. Classical physics predicted that the intensity of this light should increase infinitely as the frequency increased, which clearly wasn't happening. Another puzzle was the photoelectric effect, where shining light on a metal surface could eject electrons. Classical theory suggested any frequency of light should work if it was intense enough. However, experiments showed that only light above a certain frequency could dislodge electrons, regardless of intensity. These were not just minor discrepancies, they were fundamental challenges to the very foundation of classical physics. The universe was behaving in ways that contradicted everything scientists thought they knew. The deterministic clockwork universe was beginning to look a bit shaky. These anomalies hinted at a deeper, more bizarre reality operating at the atomic and subatomic levels. A new theory was needed, one that could embrace the strangeness and provide a consistent explanation for these puzzling phenomena. In the early 20th century, a revolution in physics unfolded, giving birth to quantum mechanics. This revolutionary theory, spearheaded by brilliant minds like Max Planck, Albert Einstein, Niels Bohr and Werner Heisenberg, proposed a radically different view of the universe. Planck's groundbreaking idea that energy was quantized, meaning it could only exist in discrete packets, laid the foundation for this new era of physics. Einstein then expanded on this concept, explaining the photoelectric effect by proposing that light itself was made up of these energy packets called photons. The quantum world was proving to be fundamentally different from the familiar macroscopic world. Concepts like wave-particle duality, where particles like electrons could behave as both waves and particles, challenged our intuitive understanding of reality. The universe was not just stranger than we imagined, it was stranger than we imagine. Quantum mechanics was not merely a refinement of classical physics, it was a complete paradigm shift. It forced us to reconsider our fundamental assumptions about the nature of reality and embrace the counterintuitive behavior of the quantum realm. Quantum mechanics resolved the mysteries that had baffled classical physics. It explained the blackbody radiation spectrum by proposing that the energy of atoms emitting radiation was quantized. Similarly, it elucidated the photoelectric effect by introducing the concept of photons, discrete packets of light energy. The impact of quantum mechanics extended far beyond explaining these initial puzzles. It provided the foundation for understanding the behavior of atoms, the interactions between light and matter, and the very structure of matter itself. From lasers and transistors to modern electronics and medical imaging, quantum mechanics underpins countless technologies that shape our modern world. The journey into the quantum realm has revealed a universe far stranger and more wondrous than we could have ever imagined. It has challenged our classical intuitions and forced us to embrace the counterintuitive nature of the quantum world. And as we continue to explore the depths of this strange and beautiful realm, one thing is certain: the quantum revolution is far from over.